FELICE is an EU-funded project aiming to develop next-generation assembly processes by integrating human skills with robotic automation. The system operates in two modes, manual and automatic. In manual mode, operations are entirely managed by the worker. In automatic mode, the FELICE system intelligently manages operations without manual input. The automatic mode of the FELICE system has been validated within a comprehensive virtual simulation environment, enabling safe testing of its features while maintaining the full functionality of the developed modules. The automatic mode of the FELICE system integrates four key modules: the orchestrator, human-robot interaction, robot action planning and execution, and the digital twin. The orchestrator monitors the assembly line environment and allocates FELICE resources by sending commands to the human-robot interaction module. This module links the orchestrator and the robot, which is fully managed by the Robot Action Planning and Execution module. The Robot Action Planning and Execution system operates as if controlling the physical robot on the real assembly line, but it interacts with the real-time virtual simulation provided by the digital twin. The real-time virtual simulation accurately replicates all assembly line operations, offering a reliable environment for testing the system. In automatic mode, the orchestrator enables the configuration of simulation cycles, the selection of workflows for each assembly line, and the assignment of stations to be assisted by the robot. Once the automatic mode is started, the orchestrator is able to monitor all the workflow currently executed by the workers in the assembly line, detecting the starting and completion of operations in each station. This becomes possible thanks to the seamless integration of the human-robot interaction, the robot action planning and execution, and digital twin software modules that enhance the orchestrator perceiving capabilities. The integration between the software modules involved is based on a continuous exchange of data and information through ROS and FIWare. The orchestrator sends out workers' instructions, robot instructions, and adaptive workstation instructions to direct the simulation. Once each command is executed, feedback loops notify all relevant modules to proceed with the next command. The human-robot interaction module translates orchestrator instructions into a format the robot can understand. Circle markers indicate the real-time positions of workers. The blue tile presents the commands currently being executed by the robot, while the green tile shows the result achieved for the commands. Commands are sent to the Robot Action Planning and Execution that manages the robot in the digital twin virtual environment. The Robot Action Planning and Execution module manages the robot's activities on the assembly line, such as picking up and handing over tools. The module first verifies the feasibility of each command, and once validated, it executes the commands by interacting in real time with the digital twin's real-time virtual simulation. All the commands issued by the orchestrator are finally executed in the digital twin real-time virtual simulation. Detailed animations are used to recreate the worker's assembly activities, the robot movements, and the adaptive workstation adjustment in completely virtual environment. Multiple cameras provide different points of views on the simulated environment, while several key performance indicators are calculated at runtime during the simulation. Both during and after a simulation, the digital twin's real-time virtual simulation enables monitoring key metrics such as assembly line productivity, worker efficiency, delays, and resource utilization. Together with the orchestrator, human-robot interaction, and robot action planning and execution, it facilitates experimentation with multiple scenarios, what-if analyses, and statistical evaluations.